Hi students, welcome to the session on array of 2 point sources with equal amplitude and opposite phase. So this is another important array analysis, right? Already I posted a video on array of 2 point sources with the equal amplitude and equal phase, right? Please refer that video, then you watch this. Otherwise, it is very difficult for you to understand this concept, right? So let us start. So since I have dealt all the fundamentals in that video itself, I go directly to the analysis. Okay, so here we have 2 point sources, right? Point source 1 is here, point source 2 is here, which is nothing but antenna, right? And we have to observe the radiation at this point P, which is far away from the distance between the distance between the point source 1 and observation point source and 2 and observation point is greater than distance between the two point source, that is R1 comma R2 is far greater than distance between the two antenna is D. That is very important, right? So that's why 1 and 2 becomes point source, right? Okay, now we go for analysis, right? We know that the electric field at point P due to point source 1 is given by E is equal to, right, EP1 is equal to E into E minus J psi by 2, right? Electric field at point 2, electric field at point due to source 2 is given by E2 e power J psi by 2. But since these two antennas are filled with the current of same amplitude, so E1 is equal to E2, that is equal to E0, because we have a current of same amplitude. So current of same amplitude produce same magnetic field, that will produce same electric field. So what is the total electric field at point P? It is due to source 1, it is due to source 2. So summation of both the field. So that is given by, instead of E1, E2, I substitute E0. E0 into E0 I take outside, e power minus J psi by 2 plus e power plus J psi by 2. Right? Now the question comes. What is that? Here both the antennas are fed with equal amplitude, but phase is opposite. So phase of one source must be opposite to the phase of another source. So what I am doing here is I change this into minus symbol. Why? Then only it is telling that it is opposite phase. Compared to this phase, this is opposite. So this indicates opposite phase. Opposite phase will give minus. So I think if I give 0 here, antenna with the phase current fed with a phase of 0, here I can fed the current of phase with current with the phase of 180 degree. Fine, so it is minus. So I put minus sign here, right? So what we have to do, we have to make appropriate changes, so it will become minus. Simple. Fine. Okay, that is a simple thing we have to do. Now we can go under analysis, right? So I didn't put a phase in at the initial time in order to make you to understand why I put minus. I kept this much of time. So from the condition, it must be opposite phase. So it must one of the electric field must be opposite to other. You can put this is minus, this is plus. That is also correct. No problem. You can follow the derivation. You will get the same answer only. Now what we do? What is total electric field? E is equal to, if you simplify, we can get 2j. It is nothing but 2j sine theta. So sine psi by 2. Psi we know already, beta d cos theta. So E is equal to 2j E naught sine, instead of psi you can substitute beta d cos theta divided by 2, because psi is equal to beta d cos theta. If you don't know, please refer my video on array of 2 point sources with the same current and same amplitude. Okay, so you see the j has come. This j indicates, from this answer also we can understand, this j indicates, right, opposite phase, right? So, and this indicates opposite phase brings additional phase shift of 90 degree. Phase shift of 90 degree. Why? How j brings a phase shift of 90 degree? When you get j, it is nothing but cos pi by 2 plus j sin pi by 2. Cos pi by 2 0 plus j sin pi by 2 1. That's what j. So it is e power j pi by 2. Fine. So this is nothing but phase e power j theta, right or no? So how much phase it has been introduced due to the opposite. So this j indicates we are getting, whenever we have a complex term j, it indicates we have a phase of 90 degree. That is very, very important. That's what I'm telling here, right? So here in the electric field we have j term. So whenever j term is present in your equation, it indicates the phase shift of 90 degree, right, in the total field. So this is not available in the same source, right? Array of fed with the same current and the same amplitude and the same phase. Here we are introducing opposite phase, so it is introducing a extra 90 degree phase shift in the total field. Right now we normalize it. If you normalize, we have to divide by maximum value. So the equation will become E by, what is the maximum value? 2j E naught. This is what maximum value of the E. So E divided by E max. Why it is maximum value? Sine has a maximum value of 1. So what is the maximum value of E? 2j E naught. So if you divide E by E max, what you get is En. En is nothing but divide E by 2j E naught. That is equal to sine beta d cos theta by 2, right? So that's what E max is nothing but here 2j E naught. Okay, maximum value of electric field. Why I write E max equal to 2j E naught? The maximum value of electric field. So for E, I have to find E max. We know that this is a sine term. Sine term has a maximum value of 1. So it's a maximum value. It won't go beyond that. So that is a maximum value. So E max is equal to 2j E naught. So E by 2j E naught is nothing but sine theta d cos theta by 2. Fine. Okay. Now we will find the direction of maximum minimum radiation, right? So we know for an array of 2-point source with the same amplitude and the same phase, we got cos beta d cos theta by 2, right? This is where already we have derived this equation. I put one video for this. Now we will see this, right? So I will simplify. Em is equal to sine beta is equal to 2 pi by lambda. D is the distance between the reference and antenna, so it is lambda by 2, not d by 2. The distance between the reference and the point source, so it is lambda by 2. From the diagram you can understand. So it is cos theta, so that is equal to sine pi by 2 cos theta En, right? Okay, so now we draw the diagram. So what will happen when you substitute theta value En and theta 0, cos 0 1, sin pi by 2 1. When theta pi by 2, cos pi by 2, cos pi by 2 0, sin 0 0, right? So 180, what will happen when cos 180 minus 1 sin pi by 2, sin minus 1, right? So that's what this one, right? Okay, then what is the thing? When theta is equal to 270, 3 pi by 2, what will happen? Cos 3 pi by 2, 0, sin 0, 0. Fine. 2 pi, cos 2 pi 1, sin pi by 2, 1. Right? Now, cos 60, cos 60, 1 by 2, sin pi by 4, 1 by root 2. Right? Let us draw the diagram. Theta 0 degree or 360 degree, 90 degree, 190 degree, 270 degree. Right? When theta is equal to 0, electric field is maximum, that is 1. So this is what En, maximum value 1. Okay. When theta pi by 2, it is 0. Right? Theta is equal to pi by 2 here, right? Theta is equal to pi by 2, so it is 0 here. It is 1. When theta is equal to 180, minus 1. This is minus 1. When theta is equal to 3 pi by 2, again 0. 270, it is 0 here again. When theta is equal to 60, this is 0, theta 0, this is 90, so it may be around 60 here. So somewhat here, right? When theta 0, 60, it is 1 by root 2. 1 by root 2 into 1, I can write. 1 by root 2 of maximum value. Maximum value is 1. 1 by root 2 is 0.7. So 0.7 may be here somewhat. So the radiation pattern will be going like this, right? When theta is equal to here, it will go like this, right? Similarly, here it will go like this and it will be coming like this. Fine. What will happen when theta is equal to 120, right? When theta is equal to 120 also, it is 1 by root 2, right? This is 60. This is theta is 60 degree, right? Here theta, okay, right. Sorry. Here theta, okay. Right, here theta is 120 degree. 120 degree also, this is 1, it is 1 by root 2 of maximum, 0.77, right? 1 by root 2 is nothing but 0.707, this point. Fine. At 120 degree, the value will be reduced to 1 by root 2. Right. At minus 60, this is what plus 60, this is what minus 60. Again, it reduces to, that's what I have written here, 1 by root 2, minus 1 by root 2. It is 1 by root 2. Similarly, minus 1 by root 2. At minus 120, it is minus 1 by root 2. We substitute theta value here in this equation and find the value. It will be minus 1 by root 2. Right? Minus 120 degree. So this is what a radiation pattern due to the array of 2-point sources fed with the same current opposite phase. You see, this is like a N-fire array pattern. It is like N-fire array pattern. So if you feed antenna with two array antenna with the same amplitude and the same current, it is broadside array. It is same amplitude but opposite phase. So it is having a N-fire array pattern, right? So this is maximum radiation, right? So here also maximum. Here it is minimum, right? So that's all about this session. If you have any doubt, please ask me in the comment section. I will clarify all your doubts. Thank you.